again, if it was just randomly thrown out there, you might not see this as a Bernoulli trial, as a binomial, but it really is the same, because what we have here is we have a number of successes, which are unsuccesses, right? 30% are defective. And we're looking at defective, I guess, from quality control standards. Finding those defects is a success, because then they don't get out there, right? So the way we want to define this is that the probability of a success is 30%. Remember, that gives us the probability of a failure. Again, kind of backwards here. 30% is the failure rate. They're defective. This is the undefective one, 70%. We need both of these. And the number of trials, we're going to quality control, we're going to use 6 airbags. So those of you going into quality control, this is exactly what you end up doing. You either reject, or it's good, or it's rejected. And when you reject it, you send it back, and maybe it can be fixed. Maybe it has to be, maybe it has to be thrown out. So find the probability exactly one of them is defective. So that's the probability that our random variable x is equal to 1 defective airbag. 1 defective. So remember, from the Bernoulli, the binomial formula, out of the 6, we're looking that we would have 1 defective. Probability of getting a defective is 0.3. We're going to get 1 of those, and then we're going to get 5 non-defective. So there's that. We just need to calculate that. And let's go ahead and hit that one up. Let's clear all this stuff out. Again, we've got 6 choose. Oops. 6 choose 1 defective, exactly 1 defective. 0.3 raised to the 1 power. Again, you don't have to put that one there, but it's always good. Oops, I forgot my multiply though. This will not get, oh cool, made some space. Nope, it didn't make it in the right place though. I need to come up to the line, second insert. Now it will let me put in the multiplication where it belongs. So that's the key when you're using your calculator. Sometimes it didn't give me the right answer and I entered it right, but notice I have the multiplication down with the 1, which I'm not quite sure. It might have given me an error or something. But and then I've got to be down on this line, multiply 0.7 raised to the 5th power. So 5 plus 1 is 6. 6 trials, 1 success, 5 failures in this case. 1 defective, 5 not defective. So that's point. And they want how many decimal places? They want 4 decimal places, 0.3025. 0. I forgot what I said already. 3025. About a 30% chance, right? Let's check that answer. There it is, 0.0325. So we got the right process. And then remember, when we go over to the next one, the next question, the B part, right, the probably at least 2 of them are defective. Now, remember, that means 2 or 3 or 4 or 5 or 6. That's 1, 2, 3, 4, 5 calculations. This is one where we want to not calculate what we want, but calculate what we don't want, which is the probability. So don't want. Probability that there's no defective or 1 defective. 2 calculations. So we're going to take 1 minus the probability x equals 0, this way, plus the probability x equals 1. So there's 2 calculations here, then we subtract it from 1. So using the same format, probability of 0 defective is going to be 6, choose 0. Again, that's 1, so if you want to be faster, you could, just get past it. It's going to be the probability of a failure, 0.3 to the 0 power. That's also 1, so you could leave it off, but I like to just, at this point, just put everything, and then 6 that were not. Do this 1 minus all of this stuff. Plus a probability that there was 1 defective, right? So that's going to be 6, choose 1, 0.3 to the 1 power, first power, and 0.7 to the 5th power. So 5 plus 1 equals 6. Those always have to be there. Get these two numbers, add them together, subtract them from 1, and that will give us at least 2 of them are defective. Okay, so, and for this one, again, you could do it multiple ways. Let me just go ahead and do this all in one line. So 1 minus 6 math probability. Go 6, choose 0 times 0.3 to the 0. It's going to have times 0.7 to the 6th. 6 plus 0 is 6. That's good. Oops, I forgot. Should probably have, well, not probably. Of course, I have to have a parentheses here. Otherwise, it would subtract this from 1, and then it would add the next value on without that parentheses, order of operations. So just, be careful about these little things. So then we're going to add, or you could subtract them both, but however you want to do it. 6 math probability, choose, and we're going to choose 1 defective. Multiply by 0.3, raised to the 1 power, and multiply that by 0.7, raised to the 5th power. And then we'll put our parentheses, and it'll do the whole calculation. We'll have exactly what we want. And the reason I might do it here is if I calculate each piece, I might add them, and then I might forget to subtract the 1, and I put that as my answer, which really wasn't correct, right? But if I do this, I get the correct answer of 0.5798. 5798 here. 4 decimal places, so about 57% chance that we have 2 or more. It's quite a chance, right? And let's do our check here. There it is, 5798. Multiple ways to do things, but just understand what's going on and remember this binomial formula that we come up with. It's actually very helpful in many other things as well, because there's a lot of things that are success failure based. Thank you.